G'day guys, I know this is a bit off topic for Bitcoin type related stuff, but I thought that there was so much detail going on in this little summary here that I thought I might break it down, and I might try a few extra towns to further, enhance what I found. So this obviously was the globe Earth versus flat Earth graph, and I did this because I'm going to try something that no one else has bothered to try. So I'm going to try to size them up side by side and do it visually and do it with my own data. So I'm not relying on anyone else's data to bring me to the same result. So I originally picked 4 cities. I picked Auckland, which was down south, and I picked Jakarta, which was dead center to the equator. I picked Athens up in Greece and Moscow in Russia. And as you can see here, most of this here is like June 21st, April 25th, which is pretty much the day that I was doing it, and then December 22nd. Of course, June being like either the peak of winter or the peak of summer, depending on what hemisphere you're in, and December being the peak of winter or the peak of summer, depending on what hemisphere you're in. So this is all roughly to scale. So this, so the radius of this actual globe is, let's have a look. So the radius is 6,356.7. So that should be the radius of what the Earth is. Keeping in mind it is every millimeter is 1 kilometer. So realistically, it's still still only the size of a house, but it's to scale. Now I interpolated that distance wise into this flat Earth map. So this distance from the southern point to the 0 point and all the way up to the north point is the same as the actual distance that the curve actually runs in. So it's not a straight line straight through. It's actually every millimeter that travels all the way around this curve is just been peeled open like an orange down here. And so these locations, where we've got Auckland at 36 degrees, Jakarta at 6, Athens at 37, and Moscow at 55, they are exact to their position as related to this. And all these angles have been doubly related over here. So what I'm going to do is I am going to introduce 2 new cities at the far extremities, and I've picked these 2 extremities here. So up in Norway, I've picked where is it? Here we go. It's about as high as you can get. So Skarsvåg in Norway, right up as high as you can possibly get. And down south, I'm going for pretty sure it's on the Chilean side. I think it's Chilean side, so it's not Argentina. So it's Punta Arenas. So Chile and Norway. What I'm going to do is, so that I can implement it, I am obviously going to have to implement the coordinates. So I'm going to use the southern or northern coordinates. So I'm going to implement these 2 coordinates on the map, and then I'm going to go to this particular website, which I found to be the best website for finding sunlight, like altitudes and all sorts of stuff. So I've got both towns. And you can just go through and click on the actual city, the date, so the 25th of April, which was when I was doing that other one, and you basically go along to here. It says heading it's either 360 north or 180 south. That basically means if it's pointing up or down, and the altitude was just a simple number. Now I personally would have loved it if it wasn't 24, but 24.15 or 156 or something like that. The accuracy would have been even tighter, but that's kind of what I've got, which I don't think is all that much of a problem. But anyway, what I'm going to do is I'm going to send this video into like a hyperspeed mode and so that way I can implement all this data, and yeah, I'll have a chat about it once I get to the end. Okay, back to normal speed. I've tried my best to get it all drawn up as quickly and as efficiently as possible. As you can see, I've put in the two cities now. So we've got the Skarsvåg from northern Norway put in. We had a 42 degrees south bearing, and we had 32 degrees south bearing for April 25th. December 22nd, it went -5. So it was under. You can't really measure that on the ground. I mean, obviously, you would assume that the sun never rises at that particular angle, but either way, it's stipulating that it's below the horizon. So not much point extending that beyond the means. In regards to Punta Arenas in Chile, at December 22nd, we got 60 degrees, so we've got quite a big angle there. April 25th is 24, and June, which should be winter, is 13 degrees. So December 22nd, that's similar to us, that's summer. And so, yeah, likely up here. So in Norway, June, that would be summertime, and December is winter. That's basically when it's just nighttime all the time, and they never get any sun. It's just freezing like an ice block. So what I did was I went and put all these angular sort of checks on there, and everything's coming out to about 1 degree. I could fine tune the thing, but it's a whole lot of mucking around to get in there and try to fix it. Maybe I'll just go in there and just fix it now. I'll see how we go. Okay, there you go. So there you go, 0.68, 0.64, 209. No, I'm reading all the reds, by the way. 0.25, so that's all those angles. 0.67, 637. Looking at the grey, strange enough, 0.637, same bloody thing. 0.637, what the hell? This one 0.75, 0.75. Where's the red one? Oh, that's 0.209, so that's a fair bit different. And that's from these two here. That's 0.25. So yeah, I mean, it's obviously done some rounding there. 0.642, and this one 0.358. So you can see that most of the angles, their deviations are within 1 degree. They don't deviate any harder than 1 degree. So that basically means, with the inaccuracy of the sun angles that website gave me, that basically means I'm always going to have that a low tolerance. So what gets really strange is when you come over to the flat Earth model and you stick these sorts of things in. Obviously, there are lines going every direction. It's just out of control. If I was to, let's say I just go and flick off all the reds, which is December, and we'll switch off all the greens, which is April. As you can see here, these are all of the, what time is it? June 22nd, June 21st. So that is summer for the northern hemisphere, winter for the southern hemisphere. So as you can see here, Punta Arenas has got the sun pointing way, way, way under all of the other cities. And I mean, the closest one that we've got for a bit of triangulation here is Jakarta, Athens, and Moscow. They all see the sun in a very similar location. But this one here is kind of undershooting it as well. So the one from Norway is undershooting. Now, this is one of the questions you always want to ask these people, is you want to ask, what height is the sun? You usually don't get an answer. But according to this, what is that? That's the, this is supposed to be, I can't remember now. Must be, yeah, there must be 5,700 kilometers. That must be what that is. Because I'm pretty sure it was something like 400. No, I reckon that scale has to be, for every millimeter, has to be 1 kilometer. So it must be 5,718 kilometers high. That's where they assume the sun is in this particular instance. If I flick it over to the December time, so that would be so that is summer for us in the southern hemisphere and winter for everyone on the flat Earth. Well, sorry, in the northern hemisphere. As you can see, Skarsvåg is not even pointing in the right direction at all. We're trying to assume the sun's somewhere over here. I mean, according to this, if we were to triangulate that, we've got a sun which is like 4,000 kilometers above the surface. But at the same time, I mean, if we triangulate these two, which are closer together, the sun could be, let's say, well, the sun could be 6,300 kilometers above. It's quite miraculous the way that the sun can actually jump around like it's in a four-wheel drive truck. But anyway, it goes up and down depending on where it is on the planet. So, I mean, I know that Auckland is directly, it's sort of like a couple of hours prior to Jakarta, like 3-4 hours sunset before. But yet, you know, when you've got Athens and Punta Arenas like lining up, you know, basically, you know, we've just got the sun just bouncing around like like a jelly bean. It's just, you know, 2,000 kilometers up to 6,000 kilometers, just bouncing around. It's really quite. It really does show you just how much the flat Earth is really telling you the truth. The flat Earth has the sun with miraculous bouncing angles, and it's jumping all over the shop. And they'll say that they say things like it's all bending or something like that. I mean, honestly, I figured out the atmosphere only bends like half a degree the other day. But are we honestly saying that the sun has to go like this? Is this the proposal? Is this how the sun bends in their perfect world? Honestly, I just don't get it. I don't get it. I mean, look, this the sun height for this one here, you can either pick 4,900, or you could pick 5,300, or you could go right to the top. Why not? Let's go straight to the top. Let's go 6,000 again. We got a pretty consistent 6,000 kilometer range here. 6,000 seems to pop up a lot, but still, I mean, it's yeah. It doesn't excuse what's going on over here, because I mean, you know, if Moscow is not that far away from Skarsgård, really, if you think about it, if you look on the map, yeah, Moscow being over here and Skarsgård being over there, they're within an hour time frame of each other. They should be pointing directly on top of each other. And they see the sun only at 2,400 kilometers above the Earth. So brilliant. You know, that's like nuclear meltdown. That's like everyone's getting a solid sunburn. And I mean, over here we've got Auckland and Punta Arenas. I mean, how do they compete? Does the sun suddenly decide to go over and visit the northern hemisphere, and then decide to jump over here? I want to go and visit the south. I'll be back over here in an hour, and I'll just change my mind. I mean, you know, it's like if we're talking about, it's like below the 15-degree line for Auckland and Punta Arenas. And then Moscow and Athens, it's over here. So it's almost like if we were to look at this on a map. Let's have a look again. So it's above Athens, roughly. So if the sun at this point is around about here, above Greece and Turkey, right? When it's lined up with there, Auckland and Punta Arenas over here, and it's about level with Jakarta, which is up about here. So the sun can be over here at one point in time on the day, on this same day, and then it could be jumping around over Turkey. So it's like the sun is over the top of Turkey, and then it's over the top of like wherever the Pitcairn Islands. Are we expecting the Pitcairn Islands to have the sun straight on top, and then it to fly over to Turkey? I don't know. You go figure. It seems like they've really got it figured out. It's just excellent work. It's just excellent. I just can't fault it. It's just absolutely brilliant. So, like, you know, there's the proof. Anyway, I'll print this off. I'll post it to Twitter. Enjoy.